Hopefully you already watched my video on why completing the square works. If you haven't, I suggest you do that. If you found that video confusing, that's fine. You're not going to have to do it like that, really. Now I'm going to do a problem how you'll typically do it in algebra, and I'm going to list the steps, and I'm also going to do an example at the same time. So I'm going to make a little table here. So I'm going to have the steps on this side, and I'm going to have the example on this side. So something like that. All right, so first step, to do completing the square. Step 1, you have to make it look like this. You have to make it look like x squared plus bx equals d. Where b and d are both constants, meaning they're just numbers. On the right side, let's take the equation x squared minus 16x plus 15 equals 0. So for instance, this one, we still have to do step 1 too, and basically we need to move this 15 to the other side. So if I move it to the other side, that would give me x squared minus 16x equals negative 15 if I subtract 15 from both sides. So that's step 1. Step 2, you need to find b and write it down. You need to write down what b divided by 2 is, and you need to write down what b divided by 2 squared is. And you'll see why that comes into play here in a minute. So first of all, b is negative 16. That means that b divided by 2 would be negative 16 over 2, which is negative 8. That's going to be important later, so I'm going to circle it. And then b over 2 squared would be that negative 8 squared. So b over 2 squared would be negative 16 over 2 squared, which is negative 8 squared, which is just positive 64. That's important. So I'm going to circle that. So b over 2 squared is in green, and b over 2 is in blue. Step 3 is going to be take that b over 2 squared that we got and add it to both sides. So add b over 2 squared to both sides. Step 3. So I'm going to rewrite the equation that we had right here. X squared minus 16x, I'm going to leave a blank there, equals negative 15. Leave a blank there. And on both sides, we want to add b over 2 squared. That was the green part, so that is 64 plus 64 plus 64. Cool. Now, what step are we on? 4 is going to be factor the left side and simplify the right. Sorry, my handwriting's so terrible. It's hard writing on the screen. Hopefully that makes sense. So step 4 is factor the left side, simplify the right. Well, let's start with simplifying the right just because it's already fairly easy. Negative 15 plus 64 is just like 64 minus 15. So I think that would be 49. The other side, we're going to factor it. Okay. This is type 3 factoring because it's a trinomial with a leading coefficient of 1. So you could, if you wanted to, and you won't have to do this, I'm going to write it over here. You could draw your x. You could put 64 up here and say multiply to get that. And they have to add to negative 16. Then you could figure that out. That'd be negative 8 and negative 8. So you would have x minus 8 times x minus 8, which is x minus 8 squared. However, it's always going to work out every single time that it's always going to look like this. It's always going to be parentheses with the variable out front, after the parentheses a squared, and then the part that goes right here in this blank will always 100% of the time be this. It's going to be b divided by 2. That's going to be -8. It's always going to work out like that because we completed the square. So the 64, the green part, b over 2 squared, was representing, if I go back here, it was representing taking this part and cutting it in half and adding it to both sides. So you had this part was -8 times -8. That's why it was 64. But that made the side length -8. That's kind of how it worked, in case you're wondering. So it looks like this. So a little note you might want to write right here is this will always end up being x plus b over 2 squared. When you factor it, it'll always end up be like that. Now, why are we doing this? Well, this is another way to solve it. And I think, like I said in my other video, is the original problem, if you don't know how to factor, you don't know quadratic formula, you can't solve this because we have the same variable, but they have different degrees. So this one is squared and this one is not. But now, do you see how the variable down here is no longer squared? We got rid of that squared and moved it to the outside by completing the square. That's the whole point. So now that we did all that, that's completing the square part. Now we just got to solve it. Now to solve it, we need to get rid of the squared part. So to get rid of the squared part, you do the opposite, which is take the square root. So step 5 is going to be take the square root of both sides and then solve. So square root of both sides, square root, square root. In fact, I'll even rewrite it. So here's our problem. X minus 8 squared equals 49. I want to square root both sides. Square root, square root. On the left side, these cancel out. Square root and a square undo each other. So you're left with x. Let me erase all these little markings. There we go. You're left with x minus 8. You can drop the parentheses now because there's nothing outside of them. Equals. On this side, the square root of 49, you know, is 7. However, 7 squared is 49. But there's also another number that you can square to get 49. That would be -7. So it could be 7, or it could be -7. So we put this plus or minus here. Now this is easy to solve. The only issue is, this is actually representing two equations. So one equation is x minus 8 equals +7. And one equation is x minus 8 equals -7. So you just have to solve both, because you know quadratics can have up to 2 solutions. For the green one, x minus 8 equals 7. If you add 8 to both sides for this one, you get x equals 15. That's an answer. For the one in orange, you would still add 8 to both sides, but you'd have -7 plus 8, which would be +1. So there's your 2 solutions. So again, the steps are get the constant on the other side. That's what we did here. Step 2 is find b over 2 and b over 2 squared. Step 3 is add b over 2 squared to both sides. That's the part that completes the square on both sides. That's why we did it. Why did we do that? Because it makes this a binomial squared, or a perfect square binomial is the technical term. Why did we want that? Because now we can take the square root of both sides to get rid of that square, like we did, and then we're just left with an equation that looks like this that really represents 2 equations, and there's our 2 solutions right here. Okay, so that's it going to be the steps to solving by completing the square, solving a quadratic by completing the square. So the last thing that can make it more difficult is what if they give you a more difficult problem that doesn't have a perfect square, and they give you like a constant in front of x squared. So here's an example of that. Here's the last one that I'll do. So what if we have 2x squared plus 20x, and I have -8 equals 0. And I'll flip back and forth here. So step 1, right there. We're going to make it look like that. So the leading coefficient has to be 1, and the constant has to be on the other side. So first of all, we don't have a leading coefficient of 1. That's the difference here. It's 2. So the first thing you do is divide everything by 2. So we're going to make it x squared plus 10x minus 4 equals 0. And that still keeps the equation equal because we divided everything by 2. 0 divided by 2 is still 0, so that's fine. If we graph this compared to this, they will be different graphs, but they'll still have the same zeros, so it's not a big deal. We're just finding the zeros. That's all. They will graph differently, but they have the same zeros, and we're only trying to find the zeros. So from here, now we have to get the constant on the other side, so we add 4 to both sides. And I'm going to leave a space there. That's what I usually do. So we just did step 1. We made it look like this with a star beside it. Step 2 is find b over 2, and b over 2 squared. It helps to color code if you can. So first of all, b should be obvious. I'll write it here. B is 10. B divided by 2 would be 10 divided by 2, which is 5. And b divided by 2 squared would be 5 squared, which is 25. This is what you're going to add to both sides. So I'm going to write plus 25 plus 25. So we just did step 2, and we just did step 3. So we found b over 2, and b over 2 squared. We did this. And we just added the b over 2 squared to both sides. That was the 25 that I added right here. So hopefully that makes sense. Now I'm going to do this step, which is factor the left and simplify the right. So simplifying the right, that's super easy. You can handle that, no problem. 29, easy. 4 plus 25 is 29. Factoring the left, remember, it's always going to look like this. And the part that goes here is going to be whatever b over 2 was. So for this problem, we know it's always going to look like this. The only question is what goes here. Well, that was b over 2. b over 2 is positive 5, so I put plus 5. Okay, that's why it helps color code it a little bit. Now, we have a completed square on the left side. The right is not a perfect square, and that'll happen sometimes. So now we are on step 5. Square root both sides and solve. So to get rid of that square, we square root. So to get rid of this, we take the square root. If I do it to that side, I have to do it to this side. So square root and the square cancel out. We're left with x plus, I'll keep the color coding going, 5 equals, the square root of 29 is not a perfect square. We should try and simplify it. 29 is not divisible by 2, not divisible by 3, it's not divisible by 4. So this one, luckily, you don't have to simplify because it's already as simple as it gets. 29 is prime. So we're just going to leave it as the square root of 29 and leave it like that. We're not going to write it as a decimal because we want an exact answer. However, we have to consider both the positive and negative solution. So that was like back here when we said the square root of 49 could either be positive 7 or negative 7. So I'm making it positive or negative square root of 29. We don't know which one. So that means that represents 2 different equations. One I'll write in red is x plus 5 equals positive square root of 29. The other I'll write in green is x plus 5 equals the negative square root of 29. We don't know which one it is. However, to make this easier, since we're not going to get exact answers from these, we can actually write it all together. So since you can't simplify the square root of 29, it's not a perfect square, that is. All you have to do is kind of ignore this part for now and just look at this part. If I were just solving this, x plus 5 equals something, to get x by itself, how would you do that? Well, you would just subtract 5 from both sides. So I subtract 5 here, I subtract 5 here. And that would leave you with x equals, which is what we want, we're solving for x, the positive or negative result of the square root of 29 minus 5. That's correct. However, most mathematicians don't write it this way. If there's a term where it's a plus or minus, since it represents two separate equations here, they usually write that second. So we're going to put this part out front. So all we're going to do is we're going to rewrite it as x equals negative 5, because we subtracted 5, plus or minus 29, like that. So this represents both our solutions. That means one solution, which I'm going to write in red, is going to be negative 5 plus the square root of 29. And then the other solution I'll write in green is going to be negative 5 minus the square root of 29. And let's see, if I go to the Desmos calculator, which I think I can do here. Let me do that real quick. So Desmos. We can type in to get rough estimates of those answers. So one of them was negative 5 plus the square root of 29. Negative 5 plus in the keyboard. Square root is here. 29. So one answer is about 0.3, let's say 9, if we round to the hundredths. And the other answer is negative 5 minus square root of 29. So the other answer is negative 10.39. If we graph this in Desmos, if we graph that original equation, this guy, it should have those zeros. So 2x squared plus 20x minus 8, I'll graph it. 2x squared and 20x minus 8 plus 20x minus 8. Okay, let me get rid of this. Let's zoom out. So as you see, that makes a parabola. Its zeros should be at 0.385 blah, 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 and negative 10.385 blah, 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 which we rounded to about 0.39. So this one, if we put our mouse over it, that is the first zero with the plus, which means this one would be the second zero we came up with. So that's one way to check your answer to make sure you're completing the square correctly. Okay, so I think that's as difficult as it gets. The only other thing they could throw at you is if instead of square root of 29, they gave you, for instance, like the square root of, I don't know, 20, and you'd have to simplify it. That would be 2 and 10 is 2 and 5. So square root of 20 would be 2 times 5. There's a pair, so that'd be 2 roots of 5. That would be the only extra step they could possibly throw at you. Anyway, so I just did 2 examples. I did the steps and I did an easy one. I did the harder example. If you get a square root that is not a perfect square, I want you to do it like this. And I forgot to put my square root there. Hopefully that makes sense. Sorry for the sloppy video. I just tried to throw it together kind of quickly. I'll attach some YouTube videos that go into it as well. That way you can see some extra examples. Thank you guys for watching. I really appreciate it.